Hello, everyone. Good morning. Thank you so much for joining us on this webinar. I think we can get started. I see people coming. Firstly, hi to each of you. I'm Anya, Business Development Manager at Kmine. And before we start, just a quick reminder to follow our LinkedIn page. That's where we keep you updated with all our latest announcements and upcoming streams. And so today we're exploring a vital topic for surveyors, the one that addresses the most challenging aspect of the work, which is surveying in diverse weather conditions. And joining us today is Eugene, a mining engineer from Kmine. Hi, Eugene.
Hi, Anya. Hello, everyone, colleagues. Yeah, I'm
Uh,
Eugene, mining engineer from Kmine, and glad to see you, everyone. So I'm excited to be here at this webinar with you. So today is an important topic. So I hope the information from our webinar will be useful for you today. So see you in the end of the stream. Thank you.
Yes, in the end of the stream, Eugene will answer your questions. And yeah, we'll see you. We'll see you in the end, Eugene.
Yeah.
So if you're curious about why the topic of the stream is so vital, it's because accurate surveying measurements are absolutely essential, even in the face of tough weather conditions. These measurements and evaluation play a pivotal role in resource optimization for mining, directly influencing both production efficiency and planning. So first, allow me to provide you with a quick glimpse of what our company is about. With about almost like 30 years of hands-on experience, we've been developing a standalone application that can be tailored to fit your company's specific needs. Our solution is versatile thanks to its modular design and making it a perfect fit for businesses of all sizes. And when it comes to pricing, we also offer one of the most affordable options, especially if you compare it to our competitors. Additionally, we do have QPs and competent persons and qualified persons for NI 43 and JOR compliant report. So if you're interested in acquiring one of these services, please let us know in the comments. Also, we are your one-stop shop for a wide range of needs from 3D modeling to resource estimation and planning. Currently, we developed 12 models that are tailor-made for companies in various phases of exploration, development, and production. And these models are incredibly versatile and can be easily adapted to suit virtually any type of deposit, whether it's underground or open pit. What's cool about these 12 models is that they can either work independently as a standalone applications or seamlessly collaborate with each other. So you can say goodbye to data sharing hassles and compatibility problems. It's like giving different departments a shared space for effortless information exchange. Plus, we've got custom solutions and comprehensive planning services, which means we're here to help you automate your production processes and streamline your workflow into a well-oiled machine. So at Kmine, we're also dedicated to focusing on the specific aspects of every mining project. This commitment drives us to provide that extra layer of support to mining companies at every stage. Again, be it exploration, development, production, our team consists of mix of professionals, including mining engineers like Eugene, geologists, planners, surveyors, and more. Their combined experience empowers us to offer a wide array of services ranging from resource modeling and mining engineering to thorough auditing. But we don't stop just implementing our solutions or setting up your company's infrastructure. Our engineers stand by as a reliable resource throughout your project journey. So whether it's crafting intricate 3D models, devising strategic plans, or estimating resources and reserves, we're here to accompany you at every turn. So if this has piqued your interest and you want to find out more, please don't hesitate to reach out to us in the comments. So now let's dive right into the main topic of our webinar. In today's stream, we are focusing on three key topics that hold significant importance in the realm of mining and geospatial surveying. So let's take a closer look at what's going on our agenda. In the first segment, we'll delve into the world of geospatial surveying, focusing on its application in diverse climatic conditions. So we'll start by exploring the commonly used surveying measurement methods and delving into the mechanics behind their operation. From there, we'll discuss why these methods are so fitting for mining companies operating in challenging climatic conditions. And furthermore, we'll explore the advantages of this surveying and data processing methods that bring to the table. Our second topic hones in on the critical aspect of volume estimation in the mining industry. So we'll kick things off with an overview of the data processing for volume estimation to give you a comprehensive understanding. And then we'll delve into how these advanced methods significantly improve accuracy and efficiency within the industry. And finally, we'll touch upon the pivotal role these advanced techniques play in shaping the modern mining landscape. And our final segment revolves around capabilities of K-Mine and what it can offer to surveyors. We'll begin by showcasing a real-world example of data processing using K-Mine surveying. And top it off, we'll provide a demo of our tools and models developed to meet the diverse needs of surveyors. So let's talk about geospatial surveying in different climatic conditions. Proficiency in geospatial surveying across diverse climate conditions is of significant importance in today's mining and geological sectors. Harsh weather conditions, whether it's fog, rain, or snowfall, or sub-zero temperatures, are challenging for precise geodetic measurements and surveying operations. But thanks to the evolution of modern technologies, the utilization of different sensors, advanced data processing methods, surveyors and engineers now have the capacity to collect and analyze geospatial data even in the most adverse weather conditions. In this webinar, we'll explore fundamental aspects and techniques that enable effective geospatial surveying outcomes regardless of weather conditions. So let's explore how technology plays a pivotal role in this context. So first, let's discuss LIDAR technology. LIDAR stands for light detection and ranging. It's highly effective for surveying mountain operations in challenging climates, and here's why. First, it's exceptionally reliable regardless of weather conditions. LIDAR can penetrate through clouds, rain, and even snow. Since it relies on laser beams rather than visibility, it functions reliably even when other surveying methods might be hindered by precipitation, fog, or snowfall. Second, it excels in terms of speed and efficiency, which is particularly valuable when surveying and monitoring mining operations, specifically in unpredictable weather. LIDAR can gather substantial amount of precise information very quickly, and additionally, it prioritizes accuracy and resolution. So in mountainous landscapes where topography plays a crucial role, LIDAR's high measurement accuracy and detailed data resolution offer significant advantages. Also, many LIDAR systems can be automated and controlled remotely, so that enhances also safety and efficiency of surveyors working in extreme climates. Another advantages of LIDAR is its ability to provide rich volume of data, which can be utilized to create highly detailed digital terrain models, analyze deformations, estimate deposit volumes, and perform other essential tasks that contribute to the smooth operation of mining activities. And last but not least, LIDAR serves as a reliable monitoring tool. So it can be used to oversee slope stability and pit edges, helping identify and advance potential hazards and risks associated with mining operations. So with all these strengths, it's evident why LIDAR is both important and so widely favored, particularly when dealing with challenging environmental conditions. So now let's explore another technology known as radar surveying. Also, it's sometimes referred as radiolocation surveying. It plays a pivotal role also in the mining industry, facilitating precise geodetic measurements and creation of images for both underground and surface objects using radio waves. This technology proves particularly valuable in adverse weather conditions we mentioned earlier, and one of its key attributes is reliability and accuracy. Even in inclement weather, it remains a trustworthy tool for measurements and mapping under challenging atmospheric conditions. A notable advantage of radar surveying is its capacity to operate effectively in various climates and penetrate certain type of light precipitation, such as rain and fog. And this method also provides valuable insights into subsurface structures, which are crucial for deposit exploration and mining surveying. Radar is instrumental in studying subsurface structures, including rock layers, voids, and fractures, greatly aiding in the planning of mining operations and monitoring the stability of rock masses. In both underground mines and open pits, radar can generate detailed 3D models of structures and monitor any changes that occur within them. Radar data is very valuable for assessing volumes and locations of valuable minerals, playing again a crucial role in mine planning. This technology also contributes significantly to monitoring mining activities, detecting changes like deformations, collapses, shifts, which are crucial for ensuring on-site safety. Radar surveying is also essential for evaluating the stability of open pit walls and slopes, enabling early warnings of potential hazards and risks. And also, the data from radar can be utilized to analyze geological structure of an area, identifying geological features, and conducting resource optimization in mining operations. So the collected radar data can seamlessly integrate with GIS for comprehensive analysis, site management, and with solutions like our K-Mine software, which facilitates this integration. So you can see how radar surveying is so versatile and powerful tool that ensures both precision and safety regardless of weather. As I mentioned earlier, mining technologies is super important when dealing with adverse weather conditions like fog, rain, snow, which limit visibility. And in addition to the ones I already mentioned, come infrared thermal imaging technologies. They are adept at detecting temperature changes, which proves invaluable for identifying hotspots like leaks or fires and mine sites. One method within this realm is infrared surveying in open pits. This approach involves the utilization of infrared radiation to glean insights into mining operations. The underlying principle here is that different materials and structures interact with infrared radiation in unique ways that allows analysis and monitoring of various aspects of open pit work. So let's explore a little bit the mechanics of this method more deeply. Infrared radiation functions beyond the visible spectrum, with wavelengths longer than those of visible light. This spectrum can be divided into various ranges, including near infrared and far infrared. The other function of this method is thermal emission. What it means is that in the far infrared range, solid objects emit thermal infrared radiation. The extent of this emission varies with their temperature. This property allows for the measurement of temperature changes within the pit, encompassing shifts in ground, rock, and equipment temperatures. And additionally, it can conduct spectral analysis of infrared emission. So to deepen the analysis, infrared cameras and spectrometers come into play. These instruments gauge the intensity of infrared radiation across various ranges. Distinctive infrared emission spectra displayed by various materials make it feasible to identify them and conduct property analysis. Another function of this method is the ability to monitor temperatures and thermal anomalies. Infrared surveying takes on the role of temperature monitoring within the pit. This not only helps in maintaining safe temperatures levels, but also aids in detecting thermal anomalies, which can flag equipment issues or even the presence of underground heat sources. Also, infrared imagery can be applied to assess surface deviation and deformation. Surface temperature or composition changes can indicate shifts in rock masses or alteration in structural integrity. So, a final notable advantage of infrared surveying is its contribution to safety and environmental protection within mining operations. The detection of temperature changes and thermal anomalies can provide early warnings of potential hazards, and this way, infrared surveying plays a crucial role in monitoring and analyzing mining operations, and also can be effectively integrated with other geodetic and geophysical methods to provide a comprehensive understanding of the site conditions and changes. So, when we talk about surveying, we can't avoid talking about drones. Drones come packed with a range of sensors, including cameras, LiDAR, thermal cameras, making them incredibly useful for aerial photography and creation of precise terrain maps. By blending these technologies, mining companies can access more accurate and reliable data even when facing adverse weather conditions. This aids in project planning and project management and enhances on-site safety, mitigates risks. So let's touch on the crucial aspects of data processing in drone surveying. The data processing, as you can see on the slide, has several methods that can be employed to enhance quality in challenging weather conditions. It helps to minimize the impact of weather conditions on survey quality at mining sites. So one of these methods is known as data filtering. It allows for removal of noise and artifacts arising from factors like rain or snow. And techniques employed here may include median filters, data smoothing, and noise removal. Another crucial technique is geometry correction. This process addresses distortions induced by atmospheric conditions, involving corrections for atmospheric scattering and distortion. To further enhance the quality of data under the influence of adverse weather, there is also the approach of combining data from different sources. That includes radar, LiDAR, optical imaging, and others, and also can be integrated to provide a more comprehensive and accurate picture. Thermal and infrared imaging operates independently of visibility and excels at detecting thermal variations and making it valuable in low visibility conditions due to rain and snow. Computer vision algorithms are instrumental for automatic object recognition and image filtering, helping remove unwanted elements and related to weather conditions. For those that seek automation, specialized geodata processing software can automatically correct and filter data based on weather conditions. In situations where surveys occur in low visibility conditions, there is time compensation. It's basically utilizes data collected at different times and adjusted to create more precise and comprehensive images. Overall, the choice of data processing methods depending on specific weather conditions, tasks at hand, available technologies, and more often than not, a combination of these methods proves to be the most effective approach, ensuring high quality results in geospatial surveying at mining sites under different weather conditions. So, essential techniques for estimating volumes in a pit are pivotal in shaping the assessment in mineral reserves and formulating production plans. So, let's dive into the overview of selection of these methods. First, let's discuss an approach known as area extrapolation. Area extrapolation is a volume estimation method that relies on measuring and analyzing various sections within the deposit. It operates under the assumption that geological characteristics and deposit geometry remain consistent across different sections. In this method, the areas of known sections in the deposit are measured, and their average value serves as the basis of extrapolating to unknown sections. The total volume of the deposit is determined by multiplying the average data by the depth of the deposit. Advantages of this method include its relative simplicity of the application and its capacity to provide volume estimates when the deposit exhibits a consistent geometry. So let's look at another method known as solid extrapolation. Solid extrapolation is more precise volume estimation method that considers the three-dimensional geometric attributes of the deposit encompassing its shape, size, and orientation. This approach entails creating three-dimensional models of the deposit utilizing data derived from drilling or geological surveys. This solid model serves as the basis for estimating volume. Solid extrapolation surpasses area extrapolation in accuracy and is well equipped to handle intricate deposit geometries. It is particularly well suited for more complex deposit structures. The next method is surface comparison method. Surface comparison entails the comparison of two or more surfaces of the deposit which can have been captured in various stages of extraction. By examining the surfaces, it becomes possible to discern changes in deposit volumes resulting from mining activities. This facilitates the estimation of both the material that already been extracted and the remaining reserves. The advantages of this method lie in its effectiveness for monitoring extraction processes and resource management. And now let's dive into the concept of point cloud interpretation. Point cloud interpretation is a technique harnessed in modern geodetic and geological surveys employing laser scanning and LIDAR technology to generate point clouds. These point clouds represent three-dimensional information about the deposit. The way it works is it analyzes various parameters, including geometry, height, point density, and others, to ascertain the deposit volumes and characteristics. One of the key advantages of this method is its ability to offer high accuracy and meticulous details when evaluating the volumes and geological characteristics of the deposit. The selection of a volume estimation method hinges on factors such as the deposit complexity, available data, and project-specific objectives. In most scenarios, combining different methods can yield the most accurate and reliable results. So now let's explore how surveyors and mining engineers can integrate data from the surveys into the routine tasks of a mining company. Let's consider some of these tasks. In mining, point cloud interpretation entails deriving valuable insights from extensive 3D point data sets obtained by laser scanning. Our experts at K-Mine actively engage with this data, utilizing it to identify geological features, evaluate terrain conditions, and plan mining operations with remarkable precision. This detailed point cloud data enables the enhancement of digital twin representations, including various objects like equipment. Such interpretation serves to optimize drilling, blasting, excavation processes while also enhancing safety and resource management in mining operations. So let's take a closer look at K-Mine surveying model. It is designed to specifically serve surveyors in the mining industry, addressing a wide range of needs and tasks. And a notable feature of this model is its capacity to process and analyze textured surfaces. This empowers surveyors to create highly detailed 3D models of mining sites, enabling in-depth geographical analysis and precise mineral extraction planning. Furthermore, our software excels in integrating data from various instruments and tools into the surveying database, and that ensures data integrity and timeliness. This also supports well-informed decision-making and operational optimization. Our surveying model extends its functionality to include designing road profiles and pit sections. This enables a more precise determination of optimal drilling and blasting location, enhancing planning and monitoring processes. Also, our model offers robust volume analysis capabilities, and that allows surveyors to conduct precise calculations. This leads to more accurate drilling blasting decisions, and that results in basically cost savings and increased operational efficiency. The system effectively addresses transportation challenges by optimizing routes and coordinating pit movements, ultimately reducing material handling time. And the last but not least, it seamlessly integrates with modern drones, and which provides valuable aerial data and enriches analysis, deepens the understanding of mining sites. This also helps in informed decision making for improved operational performance. So you can see how overall our surveying model serves as a valuable tool that streamlines the work of surveyors by enhancing precision and the overall manageability of mining operations. So as I mentioned earlier, in the realm of mining, point cloud data plays a pivotal technical role. So let's explore how surveyors and engineers can harness point clouds alongside K-mine model for drill and blast. This process commences with extensive collection of data points through laser scanning, culminating in an intricately detailed 3D representation of the open pit. This data significance becomes evident in its application to drilling and blasting operations. Surveyors and engineers leverage the precision of point cloud data to meticulously design drilling and blasting plans. This streamlines the identification of optimal blast patterns and drilling locations, and in the end, it results in enhanced efficiency and accuracy. From a technical standpoint, the advantages are also manifold. Precision in drilling and blasting translates into minimized material waste and optimized fragmentation, which leads to, again, cost savings and superior resource management. This precision also bolsters safety as accurately positioned drill holes and control blasts reduce risks. Furthermore, point cloud data simplifies workflows for specialists. So engineers can conduct more effective pit topography analysis, while surveyors can monitor real-time blasting outcomes, enabling prompt adjustments. In essence, point cloud data serves as a technical tool elevating the precision and efficiency of drilling and blasting operations, and it delivers tangible benefits encompassing resource optimization, cost reduction, safety enhancement, and streamlined workflows for mining professionals. One of K-Mine System's prominent and commonly used features is surface comparison we mentioned earlier, and it's located in our surveying model. This capability is crucial for maintaining the accuracy of mineral extraction operations. It offers precise tracking of extracted rock mass volumes month by month using high resolution surfaces, point clouds, or frameworks along with automated analysis. The feature not only calculates exact extraction volumes, but also identifies deviations from planned mining areas. So Kmine users can tailor calculations to specific areas, adjust accuracy levels. Moreover, there is an option to employ a block model in calculations. That enables users to determine mine rock types and their masses with precision. This level of accuracy enhances economic efficiency, supports environmental impact assessment, and empowers mining companies to make informed decisions for sustainable and profitable operations. And in Kmine, we're here to assist them in such calculations. The next feature allows surveyors to automatically identify rock grain sizes based on survey data. Our model, Kmine grain size, simplifies the process of downloading and calibrating source images. It also includes statistical processing for grain size analysis, enabling the determination of piece size distribution by fractions and generation of comprehensive reporting documentation. The precision of grain size calculations hinges on optimally selected parameters like brightness, contrast, bound, minimum, density, and shadow direction you see on the screen. Enabling display rock boundaries option reveals the preliminary boundaries of rock pieces on the processed image. When you adjust the setting values in the calculation setting dialog box, the boundaries are recalculated automatically. Displaying rock piece boundaries also helps in determining the optimal filter parameters for survey processing. The most accurate grain size calculations occur when these boundaries most precisely define the largest number of individual rock pieces without segmenting them into multiple boundaries. And last but not least, Kmine model that is worth mentioning in the context of surveying is Kmine infrastructure. It is designed to maintain an electronic master plan for industrial, residential, or combined areas. This complex enables the creation and integration of a 3D electronic model for enterprise infrastructure. This model can encompass various graphical and semantic elements, including buildings, facilities, transportation and energy lines, terrain features, hydrography, topography, and more. Elements can be represented both as 2D or 3D models, along with legends conforming to standards or just user specifications. Also, modeling can be based on cartographic materials such as maps, diagrams, aerial and space photography, scanner results, etc. Plant engineering departments can utilize the model to access current data about pipelines, buildings, power lines, wells, transportation lines, and other ground and underground industrial facilities. Social information also can be imported from various formats, loaded as raster images or acquired from electronic measurement devices like tachymeter or theodolites. The plant's infrastructure management system also can be centralized on a single server with user right differentiation. So this ensures robust data storage and utilization, and it allows the management of specific data for authorized user groups. So now we'll see if we have any questions here. And I invite Eugene to join us. One of the questions actually was, how do you merge surface measurements with the drone data? So actually using our software, you can combine such data in a single system. You can also perform other operations related to analysis and calculations based on this data. Another question is, Eugene, what method among surveying method is the most versatile?
Um, well, the most versatile surveying method depends on specific goals, and all of them mentioned methods have their own advantages and limitations. But frankly speaking, I like leader, and I think leader is often regarded as the most universal for surveying mining operations. Leader provides um, like high measurement accuracy and a wide range of functions. So creating digital terrain model and detecting changes, it's no problem. Adverse weather conditions doesn't matter. So I believe the most optimal method is leader.
Got it. And which software do you recommend for processing surveying data?
Um, we're confident in our software, so we can recommend Keyman, it for sure. And with our software, you can directly upload surveying data into Keymine. However, if you already have some specialized software where you perform some very specific operations, you can always use a combination, uh, like combination of two systems. So for example, Keymine plus your software.
The other question is was from Jeffrey or Joffrey. Sorry if I pronounced it incorrectly. He asked if, as you go deeper, you find that the original bed boundary is not correct and there is either much more resources or much less. You stop and do a detailed analysis to reconfigure the model. So, of course, our software allows the user to correct that at any time. So, if that happens, you can quickly correct it.
Yeah, therefore, if such situations happen, we can quickly correct it. So, yeah, if an unreliability of the initial resource boundary or a significant imbalance in resource is detected, detailed analysis and correction of the this measurements model we can correct quickly. So,
And another question, what hardware can your software work with?
yeah. um, It doesn't matter what hardware you use for the survey, but more important is the data. Um, is like the data format. Keymine supports the most popular formats such as LAS, CSV, TXT, uh, XYZ formats, and we are constantly expanding this list because equipment is improving very quickly, and it's important for us to keep up.
Yes, and also I just want to mention that if you have a current hardware which has, let's say, API or has software, and let's say there is no integration yet in Kmine, based on the request, we can actually integrate our software with this hardware just customly for you. So that's
Yeah,
actually the difference between our software and maybe our competitors because we actually adjust our software based on the request from our customers.
for sure.
Um, the other question that I have is, does your software create 3D model directly from the drone imagery, or do you need a third party to do that?
Uh, it depends on the goals. So, as I mentioned before, um, if you have your current software where you perform some specific some very specific operations, you can use like a combination of two systems, Kmine plus your software. But if you use the most popular formats, as I mentioned before, so you can use Kmine directly for the process your data.
And Credo asked, what is your percentage of accuracy when it comes to your fragmentation analysis?
It depends on on weather condition, depends on equipment. So uh, I'm not sure I can answer in detail now because I don't know all details, all information about your equipment, about your open pit conditions. So contact us, and I will provide you an answer after the webinar.
Absolutely. So, Credo, if you can send us exactly the equipment that you're using, we would be able to give you a more precise response regarding that. And finally, also, Geoffrey asked, how many times do you need to survey using the drone?
How many times do you need to survey? It depends on size of your um, terrain. So the square is like
As many times
deep.
as you need. That's the answer. As many times as you need.
Yeah, yeah, for sure. So um, we can do some recommendations. So because it depends on conditions um, of your uh, deposit. So contact us and we will provide you all information about the recommendation, about the accuracy. So it's not a problem, but we need more information, more details.
Got it. Well, I think that's it for now. Thank you so much, Eugene, for your answers. Thank
Thank
you
you.
so much, everyone who joined this webinar. I guess I'll see you next time. Next time will be our final, we think it will be our final webinar of the year. So please don't miss it. Thank you so much and have a good one. Bye.
Have a good one.